Now I've shown about how to do regression in SPSS, but the important part of this is quality control. So once you finish the SPSS regression, you've got some extra columns of data that you can then use for subsequent analysis. So the first thing you need to look at is residuals. So you plot the independent variable against the unstandardized residual. What you're looking for is nothing. You shouldn't see any pattern. It should be randomly above 0 and below 0 to equal amount. So it shouldn't be either more above the line or below the line. And they should be a scatter everywhere. So there shouldn't be any particular trend, so that you've got more above the line at one end and more below the line at the other end. If you see a pattern, then probably it's either not linear or you've got a problem with outliers. If you studentize the test, then you should expect that all the values should be less than 2. Another thing you can look at is the Cook's distance. So what you do is you plot the independent variable against the Cook's distance, and I've added a reference line which is the mean plus 2 times the standard deviation for the Cook's distance. So in this case it's 0.063 plus 2 times 0.058, so it's 0.179. If you had any values above that line, they would be exceptionally unusual values and therefore outliers, and suggesting you need to take a look at them. For the leverage plot, you always end up with this parabolic U-shaped curve. So when you plot the independent variable against the leverage, that's because when you get close to the mean, the midpoint of x and y, so the mean of x and the mean of y, that particular point acts like the sort of central fulcrum of the rotation. So imagine you put a pin through the mean of x and the mean of y, and you use that to pin the line that you're going to fit through your data. So what you have is the points at the end can rotate that line by a lot, but in the middle it's always rotating about that single point. So the minimum leverage, the lowest leverage, the leverage of 0, occurs at the mean of x. And as you get to the extremes, they have more effect on the actual slope of the line. In this case, there is some hint that one of the ends might be having more effect than the other. So what's happening at high food consumption might be having a disproportionate effect and changing the gradient of the line slightly. So the reference line in this case is the mean plus 2 times the standard deviation. Again, so it's 0.077 plus 2 times 0.098, it's 0.273. Any values above that are possible outliers. It doesn't mean they definitely are, and if you look at the way that curve is shaped in terms of the U, it seems a natural progression. So this would suggest that probably that's not so much of an outlier. It is still a point that you need to look at and make sure that you believe in that particular data point and believe that it's likely to not have any bias or other effects in it.